So this is the next video about, and I'm going to concentrate on the planned flow rate. We'll then go on to the design of the airlifts and then go on to the actual air pump itself in terms of selection. I've done real world checks, so I've actually measured this and worked out all the flow rates, and I have the calculations here. But let's start with the first piece, which is, let's start with our sort of flow rates. So our flow rates, as we worked out here, what I've done is I've measured I know what flow rate I need. This is a 14,000 litre pond or thereabouts, so therefore I need at least 14,000, probably better if it was 2 times an hour flow rate. So 20,000 flow is fine. Okay, and from this I've measured from here to here, from there to there. So I know I need 20,000 flow rate, and I know that therefore for 2 airlifts I need 10,000 per airlift, and I've actually validated that this is what I've got actually through these calculations. So I've actually got, at the moment, got 20,000, basically 22,000 litres per hour running through this system. Now the 10,000 or 11,000 per airlift is important. The reason for that is, from this number one, we have our flow rate we require for our pond, for our airlifts. We also have the height level difference that we need. Okay, so in my case it's only about 4 centimeters. If I needed more, then I would need to work that out and to build that into the calculation. There's a site here called plantservices.com. They're a US site, so they have a US units, but this is where I got this information from. So this basically provides a research article that tells you how to work out the pressure and volume of air required for a particular flow rate with a particular size ratio between the lift above, if you were coming above the water level, and the submerged depth of how far the actual tube goes down. Okay, and through this calculation you can work out the actual flow rate per US gallon per minute, and then also the pressure difference. The pressure is very simple. All it is just the depth times by the water, specific gravity or whatever, and that gives this your pressure. But these are 2 important things, because number one, your selection of your air pump comes off this, but also number 2, you want to guarantee your flow rate and also understand how deep this is going to be. So I have gone through and done this in real world for as part of the actual calculations. Now I've reversed these calculations on what I've measured. So now what I've did is I know that I need with a 0.4, which is that number of feet, flow rate, which is actually this, which is per airlift. I need to have this number of gallons per hour. Converted to minutes, I got caught out by this. Converted to minutes, this formula gives me the amount of air required. So by going through and doing that, my airlift is roughly about 5.1 or 5.1 feet high. So it actually goes down quite deep here. The airlift gives me this number of cubic feet per minute, which is 0.344, which when I convert to litres gives me about 9.7, or in the case of these 2, give me about almost 20 litres per minute required by the air pump. Okay. Now the key part here is, people go, well, what about the pressure? Well, the pressure remains the same. I mean, you're pushing the air down a certain depth. Okay, that certain depth is very simple. Now ignore this part for the time being. The depth required is 2.62 psi, or 18.7 I think it is, or 18.09 kilopascals, which is the other pressure metric or unit, sorry. So from that we know our pressure and we know our litres per minute. Now the key thing that we need to do is to work out that we have 20 litres per minute of our airlifts at this depth. We also then want the bottom drain, which I've got some running at the moment here, which will be, say for example, 20 litres per minute at the actually slightly more depth, because it has to go essentially deeper than the actual bottom of the pond. But I put this as 1.85. That's our maximum depth, okay? And then we've got extra if we've got bio or anything else, or if we have to vent some, that's the mechanism that we have there. So the key thing here is we take our max depth, then we work out our pressure requirements. Now most pumps that I've got in terms of the XP80, for example, it's got a max of 3 psi. Now the interesting thing is when you look at air pumps, you have the airlift, you have the pipe, and you have the air pump. Now, as you can see from mine, I've got each one of these is a 32 millimeter or 1 inch air pipe. And the reason why that's important is it affects your flow rate, and it must support the pressure that you're going to push through it. So most of the time you won't have a problem. These things are like 10 to 16 psi max, so you won't have a problem. However, the flow rate is when you look at the flow rates, and there was another article I remember seeing about pipe diameter and flow rates of air, and it looks something like this. If you looked at an eighth of an inch, it actually comes out to something like 10 cubic foot per minute, for example. Whereas 1 inch gives you almost 1,000. So really what you want to do is you want to increase this as much as possible. So going for a 1 inch or 32 millimeters pipe work is a good thing, especially for which is about right for an 80 litre per air, for example, litre per minute air. Now the other things you need to look at when it comes to pump, and if your pump manufacturer doesn't give you a diagram that shows you the flow rate, the pressure difference across that flow rate, that flow rate difference against the pressure, but also the performance between a 60 and a 50 hertz mains input, which actually means that for a UK and European pump users, you'll get a lower performance, and the operating range and the rating. Well, that's ridiculous, because you can't specify what pump and how your pump's going to behave. I mean, it's literally like guesswork. So from our calculations we've done before, which is we know our flow rate, which is going to be roughly 40 to 60 maybe per minute here, probably a little bit more, but our maximum depth and our requirement here is 18.07 kilopascals. It means that for our operating range, it needs to cope with that. We mustn't be outside of the operating range, otherwise we'd damage the pump. And we need to make sure at that range, that pressure level, the flow rate is what we need. So by looking at I've been using high blow pumps and the XP80 simply because the magnet in them makes them more efficient. The magnet's a rare earth magnet, which is stronger, so therefore it becomes more efficient. Some of the other pumps are less performant in this way. So I'm only doing it because what I've read and basically I use. And this is how I came to the calculations. Now I went through for each of the pump variants, which is the 80, 60 and the 40 litre per minute. They've got a diagram which looks like this, and it might be marketing, but at least it's a starting point. It's better than some of the other manufacturers out there. So it tells me that it's guaranteed to provide 80 litres per minute at 14.7 kilopascals. The 60 at 14.7, and then the 40 is only at 12.8, and that's at 60 hertz. So when we actually scale down and scale it at 50 hertz and around about 18 kilopascals, the 80 does 70 litres per hour, the 60 does 40, and the 40 does 25. And if that sounds bad, you think of the other manufacturers who are probably not even giving an example of this. And then if you look at the actual wattage, here I've selected, because I need basically the best part of 60 odd, roughly, with the bio and a few other bits and pieces, and I can turn this up as well. then I need to have basically a good 60 and not be damaging the pump, so it needs to cope with the depth as well, which basically means I can't use an XP40. An XP60 would do it, but I would only get 40 litres per hour or thereabouts, so it would be on the verge here. And also the pressure difference would mean that I would be pushing very high up on this, which means it's probably a bit more difficult from a pump point of view to do the work. So instead I go for the XP80, which gives me about 70 litres per hour, minute, which is about 58 watts. So that tells me that I have the whole entire system. That's the bottom drain, which is actually restricted down, the airlifts, which have a valve on each, which means I can restrict that down to what it's got at the moment, and the bio that I've got temporarily as this thing's maturing. What that allows me to do is to balance out everything in terms of the air pressure and the air flows. The bottom drain is not valved, so that means that if there's anything over the pressure, that will be the maximum that it will actually provide. So what will happen is if I close off all the valves, then the pump will only see the maximum pressure of that. So that means that it should never ever go above this 2.6, so it's always going to be below the 3 psi. It's like a safety valve essentially, by using the water depth as the valve and the regulator. And there we go. So therefore I know that I am basically with this system, I'm doing basically about 10k per lift. Now I can increase this. I have actually done a much faster version of this, where I've turned up the air and literally just let the air rip with one of these without that connected, and I get a full rate out of it, and I mean a full rate of, it must be the best part of 20 odd thousand through it. Now I know for most gravity fed systems you'll get about 15 to 18,000 probably through one of these almost 4-inch pipes. It's a bit freezing cold, it's about 5 degrees at the moment, hence the reason I'm freezing cold. So with two of these, what it does is allows me to drop that a little bit, so that I'm always running very low friction. This is the reason why I have two returns, and I can see this by measuring the difference in levels, using a laser line and then measuring the level down and showing the difference. So even though I have 4 centimeters difference here, there's only 0.5 of a centimeter difference between the back of the filter and this pipe here, the water level that's coming out of this pipe, and also the same with the pond and the actual drum intake as well. There's only 0.35, so it shows you that they're very low. I have 2 of these pipes for those conduits basically. It shows that it's very low restrictions here and here. And the major restriction that I have in this system is my 16,000 rated litres per hour drum, which is probably about right when it's clear like this. It will quite happily do more, which is the reason why it's doing basically this 20,000 litres per hour. As soon as I get more dirt, or if I put in something that causes a lot of dirt, this goes nuts. And the reason for that goes nuts is the difference in rating versus the actual literage I got through an hour. And what happens is this will go straight up, it will actually overflow into the chute, and I'll lose a little bit of water. And this whole pond sits working off the level mechanism here to prevent overflow. Is that if there's more rain, etc., it will go down the chute. So the whole system has been leveled out in that way, and the water levels match in that way. Okay, so I thought I'd just give you a summary, a 15-minute summary basically, of how I've calculated going through. And I'll take a photo of this and put them on the forums as well, and how I've calculated and how I've then selected which pump I've worked through. When I looked at the pumps, I looked at virtually all the manufacturers in Europe. That includes Charles Austin, that includes EA, that includes Medic, I forgot the name of the piston pump ones as well. And then I looked at high blow as well. And that's really what, looked at the actual figures, went through all of their stats and everything, and compared them to what I need here and what information I've got to make that decision. And that's basically what I came down to. High blows, 80 litre per hour minute pump, the XP80 beats the old version of the pump in terms of performance for wattage. But the XP80, that is basically why I've selected this. Okay, so there we go, and I'll put that up, and I hope that was a little bit of interest for you rather than the usual look at my pond, and shows a little bit of math behind the working out. You can use this same principle to work out, for example, your flow rate and your size of your airlifts required for your pond. And you can work out whether you want to put it at the front of the pond or whether you want to put it at the back of the pond. The main thing, as I said before, is to check to ensure that your levels and your level differences, and this is the reason why I say focus on that first, because as you come up, you can see it's fine here, but if I look at my front of my thing, if I go up much further here, as I try and push more flow rate through, this will start to get close to the edge, and the same with my skimmer as well. So just something to think about when you're building a pond, and if you want to build it with airlifts rather than just retrofit airlifts in as well. Okay, I'll talk to you soon.